Okay, so here's a video on how to find the derivatives of multivalued functions by applying the method called partial differentiation. And again, partial differentiation, that is the process of finding the derivatives or partial derivatives of functions of two or more variables. Say if we let f to be a multivalued function of the form f of xy, and if we hold y constant, then the derivative of f with respect to x is denoted by this symbol, and this is read as the partial derivative of f with respect to x. And if we hold x constant, then the derivative of f with respect to y is denoted by this symbol, and this is read as partial derivative of f with respect to y. And other notations used by some authors are d sub 1f, f sub 1, f sub x, f sub x of xy, or df dx, or partial derivative of f with respect to x. With respect to y, the partial derivatives are denoted by d sub 2 of f, f sub 2, f sub y, f sub y of xy, or partial derivative of f with respect to y. And for convenience purposes, on this video, I'll be using this notation and these notations. Okay, so let us formally define the partial differentiation. If we let f be a function of two variables, say x and y, the partial derivative of f with respect to x is that function denoted by d sub 1 of f, such that its function value at any point xy in the domain of f is given by the limit of f of x plus delta xy minus f of xy all over delta x as delta x approaches 0, and this is your partial derivative of f with respect to x. And with respect to y, that is denoted by the limit of f of x, y plus delta y minus f of xy all over delta y as delta y approaches 0. And again, this is your partial derivative of f with respect to y. Okay, let's have some example. If f of xyz is equal to x squared minus 2y squared plus z squared, we will look for all the partial derivatives of f by applying its definition. So for the partial derivative of f with respect to x, so we will replace x by x plus delta x. So we have the limit of the quantity x plus delta x squared minus 2y squared plus z squared minus, this is the function value f of xy, x squared minus 2y squared plus z squared all over delta x as delta x approaches 0. And then the next step is to simplify this part. This is equal to x plus 2x delta x plus delta x quantity squared. And then so we have the limit of x squared plus 2x delta x plus delta x squared minus 2y squared plus z squared minus x squared plus 2y squared minus z squared all over delta x as delta x approaches 0. So by combining similar terms, x squared and negative x squared will become 0. So as negative 2y squared and positive 2y squared and positive z squared and negative c squared. And then we shall now have the limit of 2x delta x plus delta x squared all over delta x as delta x approaches 0. Our goal is to eliminate this delta x, and that can be done if we factored out delta x on the numerator. So we shall have the limit of delta x times 2x plus delta x all over delta x as delta x approaches 0. And then you can now cancel this out. And then we shall now have the limit of 2x plus delta x as delta x approaches 0. And then you can now replace delta x by 0. So we have 2x plus 0. And then we shall have the partial derivative of f with respect to x equals 2x. And for the partial derivative of f with respect to y, so y is to be replaced by y plus delta y. So we shall have the limit of copy x squared minus 2 times y plus delta y squared plus z squared minus x squared minus 2y squared plus z squared all over delta y as delta y approaches 0. And then y plus delta y is equal to y squared plus 2y delta y plus delta y squared. And then you introduce negative to each term inside, and then we combine similar terms. So we shall have x squared minus 2y squared minus 4y delta y minus 2 times delta y squared plus z squared minus x squared plus 2y squared minus z squared. And then we shall combine x squared, negative x squared, negative 2y squared, positive 2y squared, and z squared and negative z squared. So what is left on the numerators are negative 4y delta y minus 2 delta y squared. So we shall have, and then again, to eliminate delta y here, we by common monomial factor, so we shall have limit of delta y times the quantity negative 4y minus 2 delta y all over delta y. So you cancel this out, and what is left is the limit of negative 4y minus 2 delta y as delta y approaches 0. And then you can now replace delta y by 0. So we shall have negative 4y minus 2 times 0. And finally, we shall have the partial derivative of f with respect to y, which is equal to negative 4y. And then finally, for the partial derivative of f with respect to z, z will now be replaced by z plus delta z. So we shall have the limit of the quantity x squared minus 2y squared plus z plus delta z squared minus the quantity x squared minus 2y squared plus z squared all over delta z as delta z approaches 0. And then again, you simplify this part. This is equal to z squared plus 2z delta z plus delta z squared. And then we shall now have, okay, x squared minus 2y squared plus z squared plus 2z delta z plus delta z squared minus x squared plus 2y squared minus z squared. And then again, you add similar terms. So what is left is the limit of 2z delta z plus delta z squared all over delta z as delta z approaches 0. And we shall now factor out delta z, leaving us with the limit of 2z plus delta z as delta z approaches 0. So you replace delta z by 0. And finally, the partial derivative of f with respect to z is equal to 2z. Okay, so this time we will be using the theorems of differentiation by applying the formulas of differentiation. Okay. Say if we let f to be a function defined by f of x, y, z equals 2x squared y minus 3y squared z minus 4z squared x, we wish to find all the partial derivative of f with respect to x, y, and z. For the partial derivative of f with respect to z, okay, so we look all the terms containing z, or containing x, sorry, containing x. So the first term and the third term contains x. Therefore, those are the only terms that you need to differentiate. So the derivative of negative 3y squared z with respect to x will become 0. Okay, so we have the partial derivative of 2x squared y with respect to x minus the partial derivative of 3y squared z with respect to x minus the partial derivative of 4z squared with x with respect to x. And then we shall have y will be held constant. So you copy y and then you differentiate x squared. So we shall have 4xy, and then the derivative of this is 0 since there is no x here. And then since 4z squared is constant, you just copy it out here, and then you differentiate x, which is 1. So we shall have 4xy minus 0 minus 4z squared, and then the partial derivative of f with respect to x equals 4xy minus 4z squared. And then for the partial derivative of f with respect to y, we shall only look for the terms containing y. So we have the first term and the second term. So we shall have 2x squared is constant, and then you differentiate y, that's 1, minus 3z is constant, okay, and then you differentiate y squared, and that will give you 2y. So we shall have 2x squared minus 3 times 2, that's 6, and then you copy yz. So that's 2x squared minus 6yz. And then for the partial derivative of f with respect to z, again, you look for the terms containing z. That's the second term and the last term. So for the second term, you just copy negative 3y squared because that's constant. And then you differentiate z, that's 1, minus 4, you copy 4, you copy x, and then you differentiate z squared, that's 2z. So we shall have negative 3y squared minus 8xz. And that's the partial derivative of f with respect to z. Okay, so let's have another example. This time we will be getting the definite derivative of f of xy equals e to the negative x tangent x plus y at the point 0 pi over 4. Okay, for f of f sub x, so that's the partial derivative of f with respect to x. So y will be treated constant. However, x appears on e to the negative x and tangent x plus y. So we will be using derivative of product. So this is our u, and this will be our v. So you have u, that's e to the negative x, times derivative of tangent x plus y, that's secant squared x plus y, times derivative of x plus y in terms of x, that's 1, plus v, that's tangent x plus y, times the derivative of e to the negative x, and that's negative e to the negative x. Okay, and then simplifying, f sub x equals e to the negative x secant squared x plus y minus e to the negative x tangent x plus y. And then what are we going to do next is to replace x by 0 and y by pi over 4. So we have e to the negative x is 1 over e to the x, where x is 0, secant squared x is 0, plus y, that's pi over 4, minus, again, that's 1 over e to the x, then x is to be replaced by 0, and then you copy tangent, then replace x by 0, and then y by pi over 4. Okay, and then we shall have this. And then to simplify, so we know that 1 over e to the 0 is equal to 1. So we only have secant squared pi over 4 minus tangent pi over 4. Now, to look for the value of secant pi over 4, we shall use this triangle. So if this is 45 degrees, that's pi over 4. This is 1, 1, and this is the square root of 2. And then for secant pi over 4, that's hypotenuse over adjacent, and that's square root of 2 over 1. And then for tangent pi over 4, that is equal to opposite over adjacent, and that is equal to 1 over 1, or simply 1. And then therefore, secant squared pi over 4 minus tangent pi over 4 can be written this way: square root of 2 squared minus 1, which is equal to 2 minus 1, and therefore f sub x of 0 pi over 4 is equal to 1. Okay, and we have this. Oops. That's 1. And then for f sub y at 0 pi over 4, so we differentiate e to the negative x tangent x plus y. And since e to the negative x is constant, we just copy it out in front, and then you differentiate tangent x plus y, and that's secant squared x plus y times the derivative of x plus y with respect to y, and that is 1. So we now replace x by 0 and y by pi over 4. So we shall have 1 over e to the 0, secant squared 0 plus pi over 4, and then 1 over e to the 0 is 1, and then we only left with secant squared pi over 4. And we know that this is equal to square root of 2 to the second power, and this is equal to 2. Therefore, f sub y at 0 pi over 4 is equal to 2. Okay, so let's have some example. If u equals x squared y plus y squared z plus z squared x, show that u sub x plus u sub y plus u sub z equals the quantity x plus y plus z. Okay, so we have u is equal to x squared y plus y squared z plus z squared x. And then to look for ux, so we only look for the terms containing x, so the first term and the last term. So the y is treated constant, so the derivative of x squared is 2x. Then the derivative of this is 0, plus z squared is constant, and then the derivative of x is 1. So we shall have u sub x equals 2xy plus z squared. And for u sub y, okay, so you look for the terms containing y. For the first term, so x squared is treated constant, and then the derivative of y is 1, okay, plus z is treated constant, and then y squared, the derivative of which is 2y, and then the derivative of z squared x is equal to 0. Therefore, u sub y is equal to x squared plus 2yz. And then for u sub z, okay, so you look for the terms containing z, the second term, and then the third term. Then for u sub z, y squared is treated constant, and then you look for the derivative of z, that's 1, plus x is treated constant times the derivative of z squared, and that is 2z. Therefore, the derivative of u with respect to z, and that is equal to y squared plus 2xz. And then the next thing to do is to show that u sub x plus u sub y plus u sub z equals x plus y plus z squared. So we shall replace u sub x by 2x plus y plus z squared, u sub y by x squared plus 2yz, and u sub z by y squared plus 2xz. And we shall have this. 2xy plus z squared plus x squared plus 2yz plus y squared plus 2xz equals x plus y plus z squared. And then the next thing to do is to rearrange this expression on the left side. So we shall have x squared plus y squared plus z squared plus 2xy plus 2yz plus 2xz. And we shall have this. Okay. And then you will observe that this is equal to, or this exhibit a special pattern on special product, okay, of the form square of trinomial. So therefore, this is equal to x plus y plus z squared, and in fact that is equal to x plus y plus z squared, which to verify, we expand the right side, and that is square of the first plus twice the product, plus square of the second, sorry, plus square of the third plus twice the product of the first and the second plus twice the product of the first and the third plus twice the product of the second and the third. And this is your x plus y plus z squared. And that is equal to this expression on the left side. Okay, another one. Say if z equals ln of x plus the square root of x squared plus y squared, we wish to find the partial derivative of z with respect to x and partial derivative of z with respect to, sorry for this one, this is y. Partial derivative of z with respect to y. So we recall that the derivative of ln of u is equal to du over u. So we shall have the partial derivative of z with respect to x is equal to, you just copy u on the denominator. So that's x plus the square root of x squared plus y squared. And then we shall differentiate x plus the square root of x squared minus y squared in terms of x. So the derivative of x is 1. And then the derivative of this is 1/2. Copy x squared minus y squared. Then this is 1/2, the square root. Then you subtract 1, that's negative 1/2, times the derivative of x squared minus y squared in terms of x, and that is 2x. Okay, and then to simplify, okay, we shall rewrite it this way: 1 plus 1/2 times 2, that's equal to 1, times x, that's x. And then you bring this on the denominator, so you will have square root of x squared minus y squared. And then the next thing to do is to rewrite the numerator as one fraction. By getting the LCD, you shall have the square root of x squared minus y squared plus x all over the square root of x squared minus y squared. And then you can cancel this out, okay? And that will become 1 all over the square root of x squared minus y squared, okay? And then for the partial derivative of z with respect to y, since, again, you do the same, you just copy x plus the square root of x squared minus y squared on the denominator, and then you differentiate this with respect to y. Since x is treated constant, then the derivative of x is equal to 0, and then we shall only differentiate this. So that's 1/2, copy x squared minus y squared, and then you subtract 1 from 1/2, and that's negative 1/2, times derivative of x squared minus y squared with respect to y, and that is negative 2y. And then you can cancel this out. Then the only thing left to do is to simplify, and that will become negative y all over the square root of x squared minus y squared. And resolving this complex fraction, and then we shall have negative y. You bring this on the denominator, so that's the square root of x squared minus y squared times the quantity x plus the square root of x squared minus y squared. And finally, you can introduce this inside the parentheses, and you have this expression. So the partial derivative of z with respect to y is equal to negative y all over x times the square root of x squared minus y squared plus x squared minus y squared. And next example, if u equals e to the x plus y all over a to the x plus e to the y, we have to show that the partial derivative of u with respect to x plus the partial derivative of u with respect to y is equal to u, where u again is e to the x plus y over e to the x plus e to the y. For partial derivative of u with respect to x, so we shall apply the derivative of quotient since x appears on the numerator and on the denominator. So we shall have e to the x plus e to the y, this is our v, times the derivative of our u, e to the x plus y times derivative of x plus y in terms of x is 1, minus the numerator times the derivative of the denominator, okay, and that is e to the x all over e to the x plus e to the y square. And then to simplify, okay, we shall factor out e to the x plus y. And then factoring e to the x plus y, we only have e to the x plus e to the y on the first term and negative e to the x on the second term, all over e to the x plus e to the y quantity squared. And then we shall have this. And then combining e to the x and negative e to the x, then that will become 0. So finally, we have e to the y times e to the x plus y all over the quantity e to the x plus e to the y square. And for partial derivative of u with respect to y, we shall do the same, okay, by derivative of quotient. So you copy the denominator here, and then you raise it to the second power. You copy it here again, and then times derivative of e to the x plus y in terms of y. So that's e to the x plus y times derivative of x plus y in terms of y. That's 1 minus e to the x plus y times derivative of the denominator. Derivative of e to the x is 0 plus derivative of e to the y, which is e to the y. And then the next thing to do, so is to factor out e to the x plus y, okay? And then we have e to the x plus e to the y on the first term and negative e to the y on the second term, all over e to the x plus e to the y quantity square. And then you combine e to the y and negative e to the y, so we shall have e to the x, okay, times e to the x plus y all over e to the x plus e to the y quantity square, okay? Then we shall have this. Okay, this is your partial derivative of u with respect to y. And then to verify that these two are equal, then we just have partial derivative of u with respect to x plus partial derivative of u with respect to y. Sorry for this one. It's y is equal to u. Okay. So we just copy this one and then we add it here. And then we have e to the y times the quantity e to the x plus y all over e to the x plus e to the y square plus e to the x times the quantity e to the x plus y all over e to the x plus e to the y squared equals u. And since the denominators are equal, then we can just write this as one fraction of this form. So that's e to the y times e to the x plus y plus e to the x times the quantity e to the x plus y all over the quantity e to the x plus e to the y square, and that is equal to u. Okay, and then we can factor out e to the x plus y. Okay, and then what is left here is e to the y plus e to the x all over e to the x plus e to the y. Is this square? Is this equal to u? And then you can now cancel this out. So what is left is e to the x plus y all over, there is 1 e to the x plus e to the y left on the denominator. And is this equal to u? When you look at the given, this is e to the x plus y all over e to the x plus e to the y, and therefore u is equal to u. Okay. Next example. Find the slopes of the surface given by f of xy equals 1 minus the quantity x minus 1 squared minus the quantity y minus 1 squared at the point 1, 2 in the x direction and y direction. The surface f of xy equals 1 minus x minus 1 squared minus y minus 1 squared. Actually, this is a paraboloid of this form. This is how this equation will look like. And this is plotted against the three-dimensional coordinate system. Okay, this is your x-axis, the y-axis, and then the z-axis. And this is your point 1, 2. And on this point, you can draw two tangent line and the slopes of which we are going to look for. So since there are two tangent line, then there will be two slopes, the one on the x direction and the other one is on the y direction. For the x direction, okay, so that means the partial derivative of f with respect to x. So differentiating f with respect to x, so you just differentiate 1, that's 0. Then you differentiate this part, that's negative 2 x minus 1 squared, and then the derivative of this is 0. So that's why the partial derivative of f with respect to x equals negative 2 times the quantity x minus 1. And then we just replace x by 1 and y by 2. Since there's no y here, and then the slope at the x direction is equal to the partial derivative of f with respect to x at 0.12, which is equal to negative 2 times 1 minus 1, and that will become 0. For the y direction, we shall be looking for the partial derivative of f with respect to y, and that is equal to the derivative of 1 is 0, the derivative of this is 0, so we shall have negative 2 times y minus 1 raised to positive 1. And therefore, the partial derivative of f with respect to y is negative 2 times the quantity y minus 1. And at the y direction, so the slope is given by the partial derivative of f with respect to y at the point 1, 2, and y will be replaced by 2. So we shall have this. That's negative 2 times the quantity 2 minus 1, and therefore that is equal to negative 2. So the slope of a tangent line at the x direction is 0, and this will be parallel to the y-axis, and at y direction, the slope of the tangent line at the point 1, 2 is negative